Mrs. Gray Math here. So today we are going to talk about systems of equations by graphing. We are going to identify exactly what is a system of equation, how do we find their solutions, and how do you solve a system of equation with graphing. So first off, this should have been a reminder from our pre-algebra. A system of linear equations is two or more linear equations with the same variables. And the solution to a linear system is an ordered pair that makes each of these true. So if you remember from pre-algebra, when we're looking at a graph, a system of equations is where our lines, okay, where our linear equations are intersect, okay? They share the same x and y value. Okay? For our purpose in Algebra 1, we are going to have a maximum of just two linear equations. But keep in mind, a system can be two or more. So with systems of equations, we have three options for the type of solutions, okay? So there are three options. The first option is it could have one solution. So looking at this graph here, you notice where I have already graphed these two systems for you. Where does this intersect? Well, it intersects at this point here. So the solution of this equation is going to be the ordered pair that both of these lines share. So the ordered pair is going to be -3, -3. Okay? That is the solution to this particular system. And notice it only crosses once. It's one solution. The other thing I want you to bring in mind is look at the slope. The slope of both of these lines are different. Okay? So if you're looking at an equation and they have different slopes, you are looking at one solution. Okay? Our next option is no solution. Okay? There is a time when we're graphing linear equations that these lines will never cross paths. They will never touch. And this is the case of parallel lines. Okay? Does not matter how far that these go on our graphs, but these will never touch. Okay? The reason being is their slope is the same. They have the same slope. The only difference is their y-intercepts are different. So here with this one, we would call this a no solution. And remember, zero and no solution, two different things. So I want you to make sure you're writing out no solution. Our next option, our final option, is infinite solution. Okay? With infinite solution, it is the same line. Okay? It is the exact same line. So to be the same line, our slope is the same and our y-intercept is the same. Okay? It may look on a graph like it's just one line, but notice here I have one line and then I have a second line. They all have so many points that they share in common. So there are so many solutions to this one. There are very many points, and we call this infinite solutions because there are many solutions. Okay? So always keep in mind that with a graphing of a system, there are three choices. You're either going to have one solution, no solution, or infinite solutions. So let's talk about how do we solve a system by graphing. Well, the first thing is you need to make sure that you have both equations converted to slope-intercept form. Okay, so slope-intercept form, your y equals mx plus b. And then you're just graphing both of those lines, okay? So graph the lines with the slope and with the y-intercept, and then determine where do they share the common points, the common x and y. Do they just share it at 1? Do they share it all along? Are they the same exact line? or they parallel lines and they will never cross, meaning they have no solution. The great thing to keep in mind is once you are able to put both equations into slope-intercept form, remember that Desmos will graph these for you, okay? Desmos will graph slope-intercept form, okay? And then you'll be able to see if there is a solution or which type of solution there is. So let's take a look at some of the problems together, okay? So let's take a look at number 1. So the first thing is, okay, here is a system because I have two equations, equation 1, equation 2, and they want me to solve it by graphing. So first, check, are they both in slope-intercept form? Are they both in y equals mx plus b? Okay. Yep, they are. So now we're just going to graph. So I'm going to graph this first line, and I'll use different colors so you can see it. So I'm going to identify my slope is -1, my y-intercept is 1, and now I'm just going to graph this particular equation, just this one here in blue. So I'm going to start at my y-intercept, and my slope tells me it's down 1 over 1, and it's a negative slope, so I'm going to go all the way down. And as I've always told you, please make sure you are graphing until you run out of room. And then I'm going to connect these points, okay, and arrows on the end because we don't exactly know when this stops. Now that I have this first one graphed, I'm going to go ahead and graph my second equation. It's in slope-intercept form. So same thing, I am going to identify what is my slope, what is my y-intercept. Well, my slope is 2. My y-intercept is -5. Okay. So here I'm going to start at -5, 1, 2, 3, 4, 5, and then my slope tells me I'm going to go up 2 over 1, up 2 over 1, and I will do this until I run out of room on my graph. And please make sure you do it in both directions. Okay. So when I graph this, and you should see I have an intersection. Okay, so the first is how many solutions does this system have? Well, it intersects at one spot. Okay, so it has one solution, and that solution is at this intersection, which is at +2, -1, and that is the solution. +2, -1, that is the solution to this equation. That's the point of intersection. Now, how can you check this? Well, take one of your equations, okay, equation of your line, and check it. Plug in your x and y, see if it makes it true. Okay, so I'm going to take my first equation of y equals -x plus 1. So -1 equals 2 plus 1, right? So I have -1 equals -1. Well, that's a true statement. Let me check the other one. Here is my second equation, my line in red. Same thing, I'm going to plug it in. So I have -1 equals 2 times +2, just substituting in my x and y coordinates, -5. So I have -1 equals 4 minus 5. -1 equals -1. Both of my equations are true, so I know that my solution is correct. Try the next one on your own and see what you get. So the first step on this one is checking to make sure, are they in the correct format for us to graph? Well, the first one is in slope-intercept form. So I know my slope is 1, my y-intercept is 5. And I'll just go ahead and I'll graph that. So I have a y-intercept of 5, 1, 2, 3, 4, 5. My slope is 1, so it's up 1 over 1, and I'm going to graph this until I run out of room, and then connect with arrows at the end. Okay. Now let's look at our next line. So here, it is not in slope-intercept form. So you need to convert this to slope-intercept form. So we're going to subtract the x on both sides. I have negative y equals negative x plus 2. And now I'm going to divide by negative 1 because I want it to be a positive y. So I have y equals x minus 2. Okay. So I know my slope is 1. My y-intercept is negative 2. And we'll just go ahead and graph this. Hopefully you've already seen what the solution could be. But so I'm going to start at negative 2 and my slope up 1 over 1. And I'll plot this line until I run out. Now, what do you notice? Is there an intersection? Okay. There's not. But hopefully you notice the reason being is look at the slope of both of these lines. Okay, my blue line has a slope of 1. My red has a slope of 1, the same slope. Okay, so these are parallel lines. Parallel lines will never touch. So there is no solution. Okay, doesn't matter how far I extend this graph, they will never cross, they will never share an x and a y. There is no solution. Try the next one on your own. So welcome back. So I'm hoping that the first thing that you should have done is you converted both of these into slope-intercept form. And when you did you notice both of these equations matched? Which means they were the exact same line. Okay? I did go ahead and graph both of them just so you can see. Okay? They share numerous points, numerous solutions. So everything along these lines is part of a solution. Okay? So this example in number 3, it would be infinite solutions. Okay? These are the same lines, okay? So there are so many points, we just can't count them. Now try number 4. You've seen an example of one solution, no solution, and now infinite solution. Okay? Always remember, convert to slope-intercept form, and you can always check your answer either by plugging in your points to both equations or checking it on Desmos. Well, welcome back, and here is what number 4 looks like. So the first thing I did is I needed to convert both of these equations into slope-intercept form. Okay. When I graphed both of these lines, I noticed that they crossed at exactly 1 point, and that was at my positive 3, 0. Okay. So this particular equation by graphing, it has one solution, and the solution is 3, 0. Okay? I hope that you enjoyed this very short and quick video on how to solve a system of equations by graphing. As a reminder, please attend tutoring or attend Math Academy if you have any questions or need further help.